Welcome back to the Revit Mind. We're back with another video in our Parametric Family series. This time, we'll be creating a parametric facade panel similar to the one shown on the screen. This family includes a few useful techniques that can help you create many different facade designs and parametric components in Revit. So without any further delay, let's get started. First, we'll open a new generic model family template and change the project units to meters. In this family, we'll create the window component that will be used later inside the facade panel. The window consists of two main parts, the glass and the surrounding frame. We'll start by creating the reference planes. One important thing to notice is that I'll place the new reference plane slightly to the right of the main reference plane. This will be useful later when we start assembling the final facade system. Next, we'll create the reference planes that control the width and height of the window. We'll then add two parameters, window width and window length. Both parameters will be associated with the reference planes and set as instance parameters. Once the reference setup is complete, we'll create the actual window geometry using an extrusion. We'll make sure to lock the geometry to the reference plane so everything remains fully parametric. After that, we'll define the glass thickness. I'll create a parameter called window thickness and set its default value to 2.5 centimeters. Finally, we'll add another parameter called window depth, which controls the depth of the window assembly. This parameter will allow us to easily adjust the overall depth of the component whenever needed. At this point, the window family is complete and ready to be loaded into the next part of the facade system. Now we'll load the window family we just created into a new curtain wall panel family. Open the curtain wall panel template, as shown in the video, and change the units to meters. Next, we'll define the panel dimensions. For this example, I'll use dimensions of 2 meters by 2 meters, but you can use any size that fits your design. We'll then create two parameters called panel width and panel length, and associate them with the main reference planes so the panel remains fully parametric. After that, we'll create the panel geometry itself and lock it to the reference planes. Once the panel is created, we'll add a thickness parameter called panel thickness, which will be set as an instance parameter. Now we're going to create another parameter called x. The purpose of this parameter will become clear in a moment, but essentially it represents an offset value based on the panel thickness plus an additional distance. We'll use it later to control the positioning of the window within the panel. Now we can load the window family we created earlier and place it roughly in the center of the panel. At this point, we need to bring all the window parameters into the curtain wall panel family. To do that, we'll use associate family parameter and create matching parameters inside the panel family. This allows us to control the nested window directly from the parent family. We'll repeat this process for all the window parameters we created earlier. Finally, we'll create two additional parameters called distance x and distance y. These parameters will control the movement of the window inside the panel. Distance x controls the horizontal movement of the window, while distance y controls the vertical movement. Together, they allow us to reposition the window anywhere within the panel and create a wide range of facade variations using the same family. To make sure the window can only move within a controlled range inside the panel, we need to add a few supporting parameters. This is actually the most important idea in this entire tutorial, because the same concept can be reused in many other parametric families. We'll create four helper parameters. Minimum distance x. Maximum distance x. Minimum distance y. Maximum distance y. We'll also create two user input parameters. Requested distance x. Requested distance y. The idea is simple. The requested distance parameters are the values that the user will edit inside the project. These are the parameters that control where the window moves. The other parameters are only used internally by the family to define the allowed movement range. Once the family is loaded into a project, these parameters can be hidden or appear grayed out so the user doesn't need to interact with them directly. To create them, go to the family editor, create new parameters, set their type to length, and make them instance parameters. Now we need to define the minimum and maximum movement limits. I'll enter the formulas shown in the video, and later I'll explain exactly how each formula works with a simple diagram. Next comes the main part, the formulas for distance x and distance y. These are the parameters that actually control the window position. Instead of connecting them directly to the user input, we'll use a conditional if statement. Let's take a look at the logic behind it. Inside the large panel we have a smaller window. The window moves horizontally using distance x and vertically using distance y. We also created a parameter called x, which acts as a safety offset so the window never touches the edge of the frame. The maximum allowed distance is calculated based on the panel width, the window width, the panel thickness, and the safety offset value x. The minimum distance is simply the panel thickness plus the safety offset. Now imagine the user enters a value through requested distance x. If that value is inside the allowed range, we simply use it as it is. If the value is larger than the maximum allowed distance, we automatically return the maximum value instead. If the value is smaller than the minimum allowed distance, we automatically return the minimum value. That's exactly what the if statement does. So if the user enters 3 meters but the maximum allowed distance is only 2 meters, the family automatically uses 2 meters. And if the user enters 0 meters while the minimum allowed distance is, for example, 0.2 meters, the family automatically uses 0.2 meters. This way the window always stays inside the valid area of the panel, no matter what values are entered in the project. It's a simple idea, but it's incredibly useful when building robust parametric families that need controlled movement and user-friendly inputs. Now that we've set up the movement parameters, the next step is to create different family types for the window. You might ask, why do we need types here? The idea is simple. The parameters we built control the window movement within a defined range, but right now everything is based on a single square window. If we change the window into a rectangular shape, either vertical or horizontal, some of the existing formulas might not behave correctly. Instead of making the equations more complex, I decided to keep the logic simple and handle this variation using family types. So the concept is, you don't change the system, you just switch the type. Each type will still use the same movement parameters we created, but the geometry will adapt based on the window shape. For example, a square window type, a vertical rectangular window type, a horizontal rectangular window type. All of them will behave the same in terms of movement, but each one has a different geometry setup. This approach gives you flexibility without complicating the formulas, and it keeps the family much easier to understand and control. Now we'll load the family into a curtain wall system. Set the curtain wall dimensions to 2 meters by 2 meters, then load the window family and assign it to the panel. As you can see, we can now switch between different types while keeping full control over the window movement using the same parameters. Next, we'll add depth to the panel to make it more realistic. We'll create a solid extrusion, then cut it using a void extrusion to create the window opening. Finally, we'll lock the void to the window geometry so it always follows its movement and stays fully parametric. At this point, the family is complete. If you enjoyed the video, make sure to subscribe to the channel and turn on notifications so you don't miss upcoming tutorials. And if you want to support the channel, you can also download this family from my Gumroad page. I've uploaded it there so you can use it directly in your own projects. Thanks for watching, and see you in the next video.